Hello and welcome to the next installment of our geometry interactive notebook flip through. So this is actually going to be a little out of order for me. After the introduction to geometry unit, I go on to transformations. But I know that a lot of geometry teachers like to do constructions at the beginning of the year, so I'm filming this video now. But I actually save constructions for last. It is one of the least tested topics on our final exam, or our state exam rather. So I would just rather like have it at the end of the year where like if I don't get to spend a lot of time on it, it's not a big deal because it's literally one question. And also it's a hands-on thing. Like there's no way to make this not a hands-on type of lesson or unit rather. So by saving it for last, it helps when students start getting like that end of the school year energy where they're just kind of like squirrely and, you know, it's just a different energy at the end of the year. I can't articulate it, but if you're a teacher, you know. So it just makes it so much easier having something that's inherently hands-on as the last thing that we do. And just a quick side note, I'm going to show these, but they're not actually in my interactive notebook. The interactive notebook that I'm using to flip through is one that I completed previously from the 2019-2020 school year. So these never made it in, and if you saw one of my earlier videos, I explained why we haven't done an interactive notebook since, but we are doing it this year. So like I said, I save this for the end and then I prioritize which constructions I want to teach, and I do not teach them all. I never have. It's just so time consuming and some of them are just kind of complicated for students. So like I said, one of the benefits of saving this for last is I can prioritize, or I kind of have to, right? Because it's at the end of the year and we need time to review. So I prioritize which constructions I teach, but I'm gonna go through the ones that I have taught every single year. So for this unit, I start and end with equilateral triangles. So basically all of the interactive notebook pages are booklets where the front page has your steps. It has the steps shown as a diagram, and then on the inside, it's just practice space. So when students are actually doing the constructions in class, I tell them don't even put your notebook near this because they need that flat open space while they're working on the constructions. So obviously this is like a big one where it's absolutely imperative that they do not put this in their notebook first, because sometimes, you know, they make mistakes or get ahead of themselves. So I start with the equilateral triangles, and in the same lesson on the same day, we also do perpendicular bisectors, because the constructions for these are basically the same thing. The only difference is instead of connecting to make a triangle, for the perpendicular bisectors, you're making a perpendicular line. So I show them that, how they're the same, and it makes it a little bit easier to differentiate between them because there's just a very slight difference at the end. But other than that, they're so similar, so it just makes it easy to lump these two together. Then on the next day, we do angle bisectors and perpendicular lines. And we again talk about how these are like almost the same thing. So your angle bisectors, you make that first arc. From that arc, you make two arcs that intersect, and then you make the line through that point of intersection. So that's really simple once they get the hang of it. And when they do, actually in the angle bisectors practice, the very last one that they get is a line with a point in the middle so that it represents that 180-degree angle. And that leads them to this when we start talking about the perpendicular lines, how, you know, it's the same kind of construction. You're going to make that first arc, you make the arcs intersecting based on that first arc, and then you're making your line through where those arcs intersect. And we just kind of go over how, you know, it's like you have that 180-degree angle every single time. The only thing that's different here is that the point may or may not be on the line, and I've seen completely different constructions done based on whether or not the point was or wasn't on the line, but you can do the same construction for both. So I just teach my students one thing, keep it simple. And then the third day that is guaranteed for me to teach for this unit is shapes that are inscribed in a circle. So we start out with the squares, which is so much fun, just doing the diameter. We do a perpendicular bisector, so it seems like a big jump from here to here, and sometimes that requires a little bit of extra explanation. And then we finish it with the lines that connect to make it into a square. So one thing that I always have to really hit home for my students is that when they're connecting these lines to make for the square, it has to actually be on the circle, because sometimes they'll pick some arbitrary point on the perpendicular bisector or the diameter that is not actually touching the circle, and I'm like, that's defeats the whole purpose of what we're doing here. But once they get that, then they're good. And then the whole inside practice. So those are all circles on the inside, which is really easy for me as far as creating this goes. And then once they have the squares, we move on to the regular hexagons. Now, regular hexagons, there's a whole story here. There's a construction that I think is, I guess I would say it's like the popular one to do, where you start out with a circle and then you place a point somewhere on the circle. You measure with your compass from that point to the center, and then you're using that measurement to make arcs all the way around the circle until you get back to the original point. However, I could never do that. Like, it always was off, that last one. It was either too close or too far away. And when that happens, you kind of get to a point where you can't actually make it into a regular hexagon. So a student of mine actually figured this out, and this is how I've been teaching it ever since. So we start out with a diameter for our first step, and then we make a nice big arc that intersects a circle twice and goes through the radius. Nope. It's the length of the radius, the measure of the arc. It goes through the center of the circle is what I meant to say. Then we go to the other end of the diameter and make a second arc so that they are touching at the center. So let me just explain that again. With the diameter, we place the center of the compass where the diameter is touching the circle. We draw an arc that intersects the circle twice and the center. We use that same exact measurement to make an arc from the other direction at the other end of the diameter. And when that happens, you have 6 intersection points on the circle, and they are all equally spaced. And then you can connect those to make your regular hexagon. Again, with this one, students need to be reminded that they are using the points where the arc or the diameter are touching the circle, because otherwise they will pick random points on the arcs or diameter to connect it. I don't understand why they think that's a thing to do, but they do. So yeah, in one period, we're doing both of these, and we're doing the equilateral triangle inscribed in a circle, but it's half of the construction for the hexagon. So once they have the hexagon down, they look at this and they're like, oh, that's cake, I got it. So it does work for me to actually do all 3 of these in a 42-minute period. But truthfully, that is rushed, and it's the nature of the end of the school year that we get through all of this in 3 days. So after that, I'll have a day of practice where they're getting actual Regents exam questions on constructions, and they're practicing. So it's like a mixed bag of different constructions, so they're seeing a little bit of everything. And then I give them a quiz on it. But that's basically it. So those are the things that I'm guaranteed to do. If we have more time, then I will incorporate other constructions. Like coming up this year, I kind of want to make sure I hit on the parallel lines just in case, because that popped up on the on the June 2022 Regents, and my students had no idea what to do. Some of them figured it out, like they're smart kids I have, but a lot of them were kind of like, we didn't learn that. And I'm like, I didn't teach that, which that's like my one thing is I never want my students to be able to say, well, you never taught us that. I'm like, nope, I taught you everything that was going to be on this test. Whether or not you paid attention is a different story. But no, I for sure did not teach them the parallel lines because it had never been put on the test before. So it wasn't a priority. And now this year I'm going to make sure that I get to that. So there's that. I'm also going to have to teach them how to copy an angle, how to copy line segments. That's something that I show them how to do on the day of like Regents practice. They do a couple different constructions based on like transformations. I show them that stuff on that day of random Regents practice of like, you can do it like this and like that. And they get it. It's not crazy difficult, but it's also rare that they do stuff like that on the Regents, you know what I mean? So there's that. And then I think once they did, and this was probably a long time ago at this point now, a line tangent to a circle. So I've taught students how to construct lines tangent to circles in previous years. You know what I'm waiting for is to have them construct like a center of a circle. That one's really fun, or even just a diameter. I've taught that one before. And then another one that I've taught, well, ones, was the centers of triangles. These ones, they get really messy. So we're talking about like the circumcenter, the incenter, the orthocenter, or the median, how to construct those. So the median is actually pretty simple. That one is hard to mess up, but for some reason, like if you're doing the in-center or the orthocenter, there's always one that's just a little bit off. So what I teach my students is to do 2 angle bisectors or 2 of the perpendicular bisectors. That way they have the 2 lines that intersect, they have that point, and they don't go into the 3rd one because that's where it looks like it's messed up. So just, they only need 2 lines intersecting to get a point, you know? So I just stop there after 2 of them and then call it a day. The only other thing I wanted to discuss for this video was the compasses that we use, but since I'm filming this in the summer, I don't have one handy. I thought I kept one in my bag, but my bag's like way upstairs. I don't feel like going to get it, to be honest. But we use these flat compasses and I love them. It's a little bit of a love-hate thing, but mostly it's love because they're so easy to use and they have the straight edge built into it so that they don't have to juggle between 2 tools. The only drawback is that you're limited to using the holes that are on there. So every now and then it will make a construction that's not completely accurate because you can't set the compass to wherever you want it. But we do have the traditional compasses at school. They just don't have a locking mechanism. So when you go to like twirl them around, they kind of open up and you end up with like a spiral instead of a circle. And so that's really frustrating. So rather than have to deal with that, we've gone on to the flat compasses and I've loved using those. I miss the compasses that we had when I was a student. They worked really well, but you know how they had that sharp point that, I don't know, I guess we can't trust kids with anymore, but those were great back in the day, but you know, it's a new time. So that is everything I have for this video. If you have any questions, please don't hesitate to leave a comment. And as always, thanks for watching.